For acute angles P and Q, sine P equals 12 over 13 and sine Q equals 3 over 5. And we have to show that the exact value of sine P plus Q is 63 over 65. So start off with two triangles, two right-angled triangles, where one of them is going to have the angle P. I'll just put P here. And the other one is going to have the angle Q. Now we need to label these. So you need to think about SOHCAHTOA. So the sine ratio is opposite over hypotenuse. So 12 would be opposite the angle P. 13 would be the hypotenuse. So that's my opposite, that's my hypotenuse. I still need to find out my adjacent. I'll do that in a minute. We also have sine Q, and the sine ratio again is still opposite over hypotenuse. So opposite Q, we put the 3. Our hypotenuse is 5. And I still need to find out the adjacent. So I'm going to have to use Pythagoras at the side here. So for the P triangle, if I'm trying to find out A squared, if this is A, B, and C, then I would need to do 13 squared take away 12 squared and square root that to find A. So I've got 169 take away 144. So that gives me 25. So A is 5. So I can put 5 here. And then for the blue triangle, same working. You know, or you might know that this is a 3, 4, 5 triangle, but show the working anyway. 5 squared, take away 3 squared, 25, take away 9 is 16, and the square root of 16 is 4. So that would be your extra working at this side to fill in the adjacents there. And now we're ready to start expanding sine P plus Q, because we have everything we need to substitute in. So the addition formula for sine would be sine cos, same sine, cos sine. So we were given sine P in the question, opposite over hypotenuse. So we can substitute that in straight away. We don't know what cos Q is from the question, but we can find that out from the triangle. So the cos ratio is adjacent over hypotenuse for the K part of SOHCAHTOA. So that's 4/5. Cos P would be K again, so adjacent over hypotenuse, but looking at the P triangle, so 5 over 13. Sine Q was given in the question, that's 3/5. Multiply the numerators together. So 12 times 4, 48 over 65, and 15 over 65. And that gives you what we wanted, 63 over 65. But you do have to show working. You cannot just substitute in the values and then get your answer here. Make sure you show the working in between for full marks.